Hi, this is Andris from Sonum International, and if you missed our webinar on the Anaplan Optimizer, this video will give you an insight on what we did, and I hope you enjoy it.
Thank you all for joining, first of all. I hope all of you are safe in the current COVID situation that's running about. I'm really glad that you found some time to join us in this demo of the Anaplan Optimizer. So what we're going to be looking at today is just a short intro, is a short intro about Sonum and Anaplan, just so you know who we are and what Anaplan is about, if you don't know that well. We're going to go over the optimization problem overview, so what we're essentially showing today. And then we're going to jump straight into the Anaplan demo. And then we could start our Q&A session. And it would be really nice if you have any questions. There's a questions bar where you can post them, so we can read them later on and answer to any of them that you might have questions on. So, start with, my name is Andris. I'm working at Sonum. Been working with Anaplan for a bit more than 3 years now. We are a international company, sort of located with offices in multiple countries: Netherlands, Germany, Spain, Latvia, and recently South Africa as well. We are specializing on working with multiple EPM tools in areas like financial and operational planning and financial consolidation. If a few words about Anaplan, if you're not that familiar with the platform. So it's a cloud-based collaborative analysis and planning platform. It's a fast to implement, easy to use, easy to build, scalable platform that can be maintained by the business owner of the process. So it's agile in that sense that you can make the changes that you need with little to none involvement from your IT departments. And because of that, Anaplan is really easy to implement across a multitude of business processes like finance, sales, supply chain. And you can really get real collaboration between departments using this platform as the single source of truth and getting some transparency in your business processes. So that being said, we're on a pretty tight schedule, so let's jump straight into the problem that we're going to be looking at today. So what we want to do is we want to show you how to optimize a particular supply chain with using Anaplan and the optimizer that is available there. So what you have available in this scenario is we're going to have customers that are going to be driving our supply chain. So their demand is the one that's driving everything afterwards. They have their demand in SKUs. It's going to be distributed through distribution centers. Then the distribution centers are going to source those products from the production plant, and production plants are going to be supplied by suppliers. So just to look at it a bit in more detail. So our customers, they have their demand per SKU in this model. They have a specific location so that we know where they are, so we know how far they are from something and somebody. And also those SKUs, they consist of packaging materials and raw materials that we have to produce, and not produce, but source in our factories and then sort of combine them to get the final SKU. For the distribution centers, we have unit handling costs per SKU available for us, so we know how much it costs to pull products through a certain SKU. We can adjust their minimum and maximum capacity, and they also have a particular location, so we know how far they are from a customer, so we know the distance between the distribution center and the end customer. That helps us evaluate the logistics costs. In addition to that, our production plants, they have a certain fixed costs that is associated with them. They have a unit production cost per SKU. Again, they also have a minimum and maximum capacity, and they also have a location, so we know how far they are from the distribution centers. So again, we can use a distance matrix to check out these variables and take them into account, especially in logistics costs. And then finally, we have our supplier distribution centers, right? So we have our suppliers, and one supplier could have multiple distribution centers that we could source our product from. So they have two different products. They have raw materials and packaging that both have to be taken into account. They can specify the minimum or maximum capacity that they can source, right? So if they want a certain contract, if we want a certain contract at a certain price, we have to buy at least a minimum amount in this scenario. And then they also have a location, so we can use a supplier and distribution center plant distance matrix. So we know how far these supplier distribution centers are from our factories or our plants. So, and when we sort of put it together, this model, it's not too big, but it's also not too small. So in total in this model, in these demonstrations, we're going to have the amount of 335 customers, 50 distribution centers, 20 production plants, and 130 supplier DCs, right? And we're going to have 4 unique SKUs, 12 raw materials, and 4 types of packaging for those SKUs. So essentially, it might not seem as too big of a problem at first, but then if you're asked the question, okay, so my customer A and B has a volume request of this in a particular SKU, what would be the best way? How can I set up this distribution chain if I know, let's say, if I plan a year advance and how to align my contracts and everything? So how to align these with suppliers and distribution centers or production plants, how we can align this easily, right? So pretty quickly, it becomes a pretty big problem, because if you just take unconstrained scenarios that everything can flow through everything, you easily get up to 2.7 trillion possibilities on how to solve this problem, right? So, and that's not even taken into account that you could have splits, right? So one customer could be getting their volume from 2 different distribution plants and distribution centers. So the problem easily and quite quickly scales up to be a bigger one. So without much hesitance, let's jump into Anaplan and see how this actually looks from the tools perspective. So this is our landing page for the optimization section. So what we want to do is we want to go in and check out our supply chain optimizer. So when we move into this section, so what we can do is we can either return to the global navigation, but essentially we can use the cards to navigate throughout our model, so we know which processes we want to do and where we want to go. Or we can also use a menu on the top that's going to display the different sections of our model, and we can, if we know where we want to go, we can go there straight away, so we don't have to go through all of the setups and through the loops of finding the right dashboard through clicking through everything. But essentially, this is what we have, right? So the model setup is going to show us all of the setups that we have available. For example, our plants, right? So we can set up, we know where they are, we know the country they're in, we can see their code, etc. And this can be done. So this is setting up our model. So this is about what we talked about, what is available for our model, and we can do it to all of the different components within this. So we can also adjust the scope if we want to sort of remove something from a scenario straight away. We want to sort of limit the size of our problem. We can do that with just taking a particular plant, for example, away from the optimization process. We can also, of course, as I said previously, one of the major drivers in this model is the customer demand forecast. So what you could have is, for example, if you have an integrated SNOP environment within Anaplan, you could be pulling your customer demand from a different model, right? So we could connect it to a model within Anaplan ecosystem that has your customer demand. But for example, in this example, we just have a input. So that would be, let's say, our assumptions on what our customers may need for the upcoming year in terms of their demand by SKU. And this, of course, rolls up into country demands because we know where our customers are located in. And then, of course, it goes also to the details of we can align our distance matrices. So this is just big sheets of information to know how far each customer is from each DC, or how far distribution center is from a given plant. So we have all of that information again available and changeable in the model. So you can adjust it as you go along, or if something changes, you have all the possibilities to adjust master data through imports or manual adjustments as well. And then, of course, we also have our cost data. So, for example, how much it costs to produce a certain product in a certain plant, right? So we can describe these production costs or transport costs and raw material costs also supplied in this model. And also we could run different scenarios with different costs that are applied. But that was mainly the model setup. So that's already been done. But what we're interested in is, okay, so we have our customer demand, how we can actually then use our supply chain to see where to pull and where to put the volume in, right? So we go into our supply chain optimization section of the model, which allows us to control what we do and actually run the scenarios that we intend to. So when it comes to input data, so you can just overview what you have available, right? So you can overview the country demand by product to see what is your total, like what is the amount of SKUs you will have to push throughout your supply chain. Then you can see how that distributes throughout your countries and what are the different availabilities in your countries, depending on the maximum amounts that you can produce, right? So this is a section where you can actually put in your restrictions, right? So you can specify the maximum and minimum volumes for your DCs, how much they can handle by SKU. The same thing goes to plants, how much they can, the maximum amount they can produce and the minimum amount they should produce to be viable as an option. And also the same thing goes to our suppliers. They could give us some details. Okay, if you want a certain contract, if you want to apply this price, then you might have a minimum. In this case, we'll not do the supplier minimums, but they indeed have a maximum saying that, okay, you can't source more than this from us. So, or if we go into our raw materials, we can also see that in tons in the components that might be sourced from a single supplier distribution center. So again, this is just an overview of your problem, so you're not getting really to a solution yet, but you can specify what is available, right? And you can see what you have. So the next thing is you can quickly, if you know something upfront, you can specify constraints, something that you might use, but this is something that we'll get back to in a second as well. But if you know anything up front, you can exclude a certain combination or exclude a certain plant or DC that you want to test. But how the optimization works itself. So Anaplan in this case is a hub for all of your data. It's all of your processes are being set up here. But the optimization is a process, right? It's not a live thing. You have to launch it. So when you want to start creating your scenarios, like first of all, you can see that the only thing we know is we have our fixed costs for plants because those are fixed. We can't really change those. but everything else is blank, right? Because we haven't really adjusted our supply chain in any way yet. So what we can do is we can start creating scenarios. So for example, because what you want to do is you don't want to solve it, you also want to see how your different scenarios compare to others. So given that we had all of those different constraints and everything, what we can do is we can run a few base scenarios just to see how our supply chain might look, right? So one of the first things that we might do is run a unconstrained scenario. So we can use a top level adjustment that it's just gonna get rid of all of the maximum constraints and all of the minimum constraints of the model. And we can run this process fairly quickly. So now we're actually getting towards our solution, right? So what our supply chain might look like. So we can see that it was a success. So we created a scenario, an unconstrained scenario. But before we go and look into the details, it will be interesting to also see some other scenarios as well, because comparing just one isn't that interesting. So what we could do as well, we could do a second base scenario, which would be our lower limits removed. So we keep our upper limits of our constraints, but we don't use the lower limits that were specified in the model. So we can specify this in here, that this is like a capacity lower limits scenario. So we run it again. And again, it's a really fast process, right? So of course it's quick because now we're just creating base scenarios. We're not going in and looking at the results of the data, but it's already giving us our top results, how much it could cost, and per different categories to run the supply chain. And of course, you can see that unconstrained scenario is way cheaper than a scenario that actually takes upper limit constraints, because I mean it goes pretty wild in allocating everything to the cheapest possible combination, which we're going to see in a second when we go into the data itself. And then of course, along with our unconstrained scenarios, we can do a proper base scenario that adheres to all of our initial settings of the model. But what it does do is it sets a base on, okay, so without doing any changes, without running any other scenarios, this is what we can achieve essentially as an overlying value. So again, you can run this process. And if you might see as well, the model is sort of tracking your progress. Like if you start a scenario, if you type in a name of a scenario, it's if you're collaborating with your colleagues or something, planning in the same time, it's gonna sort of show a process update on like if a scenario is being run or being tested, so that they know that they shouldn't maybe check out their constraint filters. But okay, so now when we have our three scenarios, we can go back and check actually our results, right? So first of all, let's dive into the details, right? So essentially we have three different kinds of results because again, the problem isn't too big, but it's also not too small, right? So we have our DC to customer volumes, we have our plant to DC volumes, and we have our supplier DC to plant volumes as well. So on the first part, let's check the volume side of what we just did. So if we go and look, so this is how the model supposes we can solve our problems, right? So this is a really like detailed planning level in terms of you can go through every single connection that was made. So for example, this is customer one, and depending on the scenario, its volume is being distributed by different DCs, right? So in an unconstrained scenario, we're just using one DC. And if we check this DC, we can also see its usage throughout the different scenarios. And we can go through checking all of the data in terms of volume and, for example, also the distance. We can see how far a customer is from a certain DC. So we can evaluate all this data and think if the result that the optimizer came up with is the correct one. We can also overview our DCs in total by scenarios. So for example, if we choose the first one, which is the unconstrained scenario, we can see why we were that much cheaper in overall cost of the supply chain than the other two scenarios. So of course, one of the main reasons is because there's a lot of volume allocated to DCs that can't actually handle all of it. So we are going over the limit quite a bit. But then if we go to the second with the lower limits removed, so you can see it's more equally distributed, the volume throughout the DCs. So this is the volume by SKU that all of the DCs should handle. But then we can also see that there are some DCs that are being used that don't really reach the limit or the minimum of what they should for us to be sort of working with them. And then that's why we have the base scenario where all of this is aligned, and we're using, if a DC has to be used to a certain degree, we're just using it towards that degree. And what we can do is, in this planning, of course, we're currently looking at all SKUs, but we can also do all of this on an SKU level. So we can see which SKU is being distributed from which DC by what amounts, right? And the same goes with the customers here as well. So if we change SKUs, we can change the DC and customer SKU combinations. So, and what we can also do from this view is, for example, if we locate the DC that we're not particularly fan of, and we sort of want to remove it, because we can see it's only being used in the base scenario, nowhere really else. So what we can do is we can start building our next scenario, just like removing this DC, and the next scenario we run, this DC won't appear anymore. So the exclusions we do are cumulative. So whenever you go through the data, you accumulate changes. And let's say, for example, as well, we want to exclude this certain customer and DC combination as well, right? So you can exclude detailed levels as well, not just the whole thing. Similar overviews can be built for other parts of the platform as well. For example, DC to plants, right? So, and this one, because we don't have so many plants available, the distribution isn't that varied, but we can again see which plants are delivering what volume in terms of SKUs to your DC. And then by checking scenarios, you can see what is our plant distribution as well, right? So when we're going really over the top, but we don't have too much resources in terms of production available, so everything is being used pretty equally throughout this scenario when it comes to plants. And the same thing goes to supplier DCs. So this is a bit more detailed in terms of that there's also packaging and raw materials come into effect. We're using a bill of materials to translate which SKU consists of how many tons of a certain raw material or which type of packaging it should be using. So we can see which plants are being proposed to be delivered by which supplier DC. And what is, yeah, again, if you check throughout the DCs, you can see how their volumes change in terms of units of packaging or in terms of tons in raw materials. So now we're looking at the total level. But for example, we know that our raw material one is actually just a packaging type. So it appears here, and this is how many we distribute from this certain supplier DC. And then again, we know that raw material 8 is a actual raw material, not a packaging. So we know how much in terms of volume we will be sourcing from them, right? So, and then of course from that we can evaluate all of our contracts and financial data from that as well. So let us go back to our optimization, right? Because we added a few constraints. We removed a DC, and we removed a certain customer and DC combination. So what we can do is we can run another scenario now, right? So this is our planning process essentially. We just ran some base scenarios, so we have some baseline costs and options available for us, and then we can run additional scenarios in terms of what is being removed, right? So we removed DC4 and customer DC33, customer 1 DC33 combination. So what we can do is we can then go ahead and run our scenario. So, and just to sort of give a bit of context what the model is going through and all of the different options that it is evaluating, because we're sort of focusing within this demo on the outlying or top level costs that you can see here. But if we go back here, so when it comes to the input data, so it has all of the parameters that we went through in the beginning available for it, right? So when it comes to, for example, plant capacities, you can see it by SKU, by plant. So it's going to be within that factor of minimum and maximum volume that it has to allocate to a plant in order for this scenario to be available. And then, of course, it's all of the customer data, DC data, plant data, also going in all of this and all of the pricing, how much it costs per kilometer, because we know the distance, we know how much it costs to distribute from a DC to a customer. So it has all of that input data available in evaluation of the scenarios. Then when it comes to constraints that we just applied, right? So it has some inherent constraints, like customer demand that it always has to fulfill, right? So we can't run a scenario without fulfilling our customer demand. But we can also specify the min-max capacities, and we can really go into a detailed level on specifying which options are available, and sort of throughout our planning process, we can accumulate the decisions that we make that these connections should not be made, or sort of are not the best to make. And then when it comes to variables, so this is how this is one of the views how it solves the problem, right? So in terms of different scenarios, it allocates volume, how much SKUs is the best to push through this supply chain, right? So, and what is really great about this is that when we define our objective, so our objective is to minimize the logistics costs. So it's not just looking at, okay, what is the cheapest option between these two parameters, right? One customer and one DC. So which DC is the cheapest one for this customer? It takes the whole of the supply chain into account when we are optimizing our total cost spent on aligning our supply chain, right? So we just want to optimize the top level costs. So all of these work together rather than independently to give you the best result that you can have. So it doesn't mean that you will always get the cheapest result per customer per DC, for example. But if you try to change it to a cheaper DC, either you're running out of constraints in that DC, or it's just not the best option for your overall optimal cost of the supply chain that you are running. So if we go back to the tool now, so we ran another scenario, so we can go and quickly look at our DC to customers, because we removed the DC. So we want to check if this constraint was adhered to. So customer 1 and DC 33 is no longer being used, right? So it was being used in the base scenarios, but now it has been switched to DC 32 because that's the best, second best option within our supply chain to allocate this volume to. And sort of we can also see some metadata. It was also a bit closer than the one before, so maybe also that could be one of the reasons why we want to specify these things. And also if we choose one of our last scenarios, you can see that DC this DC is no longer being used. So DC4 is out of our supply chain, out of our scope, so we're ignoring it completely. So its volume has been allocated to different distribution centers. So and to go back, so but what we've been doing right now is just focusing on the volume distribution and how our volumes are being distributed across our supply chain. But of course, we're also interested in our cost data, right? So how much do the cost breakdowns change throughout all of our scenarios? So we can go into a detailed DC cost breakdown. So we can see it by scenario, how much we're spending on logistics costs and shipments, how much we're spending on handling costs. And then we can also sort of see all of the different DCs. We can change the scenarios that we are looking at and sort of look how our DC costs are changing, right? And again, if we find something that we don't want, we can remove a DC from here as well. And then, of course, if we check a certain DC, we can see how its volume is changing throughout scenarios, either it's being used to its full capacity or not, and what are some underlying features of this DC, like volume in units, and how many customers are we sort of supplying from this DC, total distribution costs in terms of shipping the goods, and total DC handling costs as well in this particular DC. And we can also see some volume and then average distance covered to a customer matrix here as well. Similar analysis can be built also to look at your results on a plant level. So you can see your different cost breakdowns and how they change throughout the scenarios for your different plants. So again, you can sort of specify a certain plant, see how much it's being used throughout a scenario, if you're going over or under in our unconstrained scenarios, and how much of it is being used of its capacity. And again, we don't have too much capacity available in our plants, so most of them are highly utilized. And then we also can see, depending on the volume that we're pushing through that plant or that we want to produce, we can see our production costs, average production costs per unit, and then and sort of our shipping costs to our DCs as well. And everything that we're doing here as well, it's available also on a SKU level, right? So again, we're just sort of going over the details here, but we're sort of mostly neglecting the SKU level, but the actual planning and everything we could be doing also on a SKU level as well. So, and when it comes to our suppliers, right? So if you have some different contracts from the suppliers, we could add them as a sort of either as a default supplier or as a different supplier. So what we can do is we can check our different scenarios and how our costs change. Cost breakdown changed by supplier. We could investigate a certain supplier, for example, if we want to see how that supplier's DCs are being used throughout our scenarios. So we can specify a certain supplier and see all of its DCs that are being used, how many volumes of sort of packaging units we're suggesting to source, and how many tons of raw materials we would like to see sourced from them. And then again, of course, we can see the details throughout scenarios, how our usage of a certain supplier DC might change. But what this is sort of enabling you to do as well, for example, if you want to do some constraint planning and to see how would your supply chain cope in certain scenarios. For example, let's say you have one of your biggest suppliers is supplier number 6 in this case, and it's not been too reliable, or maybe the quality is not too good. I mean, they're good on price, so that's why we're using it initially, but we want to test out how would we cope and what would happen if this supplier would not be available within our supply chain, right? So what we can do is we can sort of, based on the analysis we want to do, we can remove a supplier and go back to our scenarios and start building a new scenario as well, right? So sort of scenario 5 in this case, which would be our supplier restrictions. And then sort of we can say that, okay, we are testing out our supply chain with removing our 6th supplier. So, and then we can go ahead and run the process to see if we can cope with a supply chain that doesn't use supplier number 6, and how would that impact our top level costs. So as you can see, indeed we can, because the scenario was successful, and our overlying costs aren't impacted that much. Of course, there is a bit of an increase, especially in the supplier DC to plant shipment costs, because inherently we have to use not as good combinations in those. But if we go back to, for example, to our overview of our suppliers, and we choose the last scenario, we can see that the volume is now being distributed through different suppliers, and we're not using the supplier 6 at all. And again, you can set these constraints up in many different ways. And in this case, you accumulate, right? So while you go through your different volume plannings or financial plannings in terms of what you want to do, your constraints accumulate. So right, when we said that this customer can't source product from this particular DC, these constraints are adhered to. You can of course clear all of them and just run completely different scenarios from one another. But what Anaplan enables you to do, and with using this optimization tool, is really to be able to run scenarios quickly, to enable a lot of users to work collaboratively. So, and you can also have your Anaplan ecosystem. If you have like an SNOP model or your demand planning model, you could be using your forecasts and see how your scenarios or how your supply chain changes depending on the different forecasts. And essentially, the real beauty of this tool is that you can enable business users to use optimizations tools easily, right? Because some other competition, it may be really difficult. You would have to use some specific programming language or anything else to enable these scenarios. But this is quick. This is also quick to build and quick to deploy, depending on your data quality, of course, and do you know your project scope? But essentially, a really good tool to put in all of your constraints and just find the best solution on the top level results, not just by finding the single solution to a single problem. You're just sort of looking at your total supply chain as a whole.
I hope you found the video useful. If you still have any unanswered questions, feel free to contact us. All of our details are in the description below.